This is a cumulative test. I'm gonna split it into two part of the test, but those are all multiple choice. Okay, so test one. Use a substitution u equals to root x to rewrite integral 0 to pi cosine root x dx. So they gave you this. So du equals this x to 1/2. So when you take a derivative, 1/2 x to the and then you subtract 1, so negative 1/2 dx, or you can rewrite as 2 root x dx. So that integral, when you put 0 into here, right? So root 0 is a 0, and then this is a root pi, okay? Because I'm gonna make in terms of u only. And then cosine of this on u, and then dx is from here. So du was this. So 2 root x du equals dx. But u is a root x, so this one 2u du is a dx. So I'm gonna replace it here, 2u du, okay, instead of dx. So when you rewrite it, then 2u you can write in the front, okay, and then B is answer. Number 2. So this one, integration by part. I want to remember this one, Riyadh, which means it has a priority to make it u, okay? So this one is a logarithm, logarithmic function, and this one inverse trig function. So inverse sine, inverse cosine, like things like that. And this one arithmetic, means a polynomial like x squared or like x, like that. Okay, this one trig function like sine, cosine, tangent, and this one exponential function. So like e to the x or 2 to the x, like that. Okay, and then this side it has a more priority. Okay, so remember this, Riyadh. So now you have arithmetic and exponential. So arithmetic comes first compared to exponential. So then x is a u. So I'm gonna say u is x and dv equals, I'm doing integration by part, e to the 5x dx. So du equals dx. And then when you take integral this one, think about chain rules. Huh? E to the 5x, but you have to put 1/5. Okay? So when you take a derivative, it'll come back to this one, right? Because e to the 5x times 5, so it cancels out, so you come back to here. So v is this. Now uv, so that becomes uv is 1/5 x e to the 5x minus v du. 1/5 e to the 5x dx. So that portion, so you can do one more step. Minus, if you consider one more time for the chain rule, so it'll be 1/5 times 1/5, 1/25, and e to the 5x plus c. Okay, and then which one is that? So when you factor out 1/25, then should it be D? Okay. Now number 3. So again, this one, if you consider Riyadh, so arithmetic and logarithm. So logarithm comes first. So u is ln x then, and dv is x squared dx. So du is 1/x dx, and v is, using power rule, 1/3 x cubed. Okay, so if you consider integration by part, uv, but let me write down. So integral u dv equals uv minus v du. Okay, That one is integration by part. So uv, so 1/3 x cubed ln x minus VDU, integral VDU. So 1/3 integral, one of the x cancel out, so x squared dx. So 1/3 x cubed ln x minus 1/3 times 1/3 is 1/9 x cubed plus c. So answer C. Okay. So how you gonna take antiderivative of arctangent? So what you can do also, this one inverse trick, and then one is hidden here, right? 1 dx. You can say u equals inverse tangent x, and then dv is basically 1 dx, or you can say just dx. So du equals 1 over, when you take a derivative of inverse tangent, is 1 over 1 plus x squared dx. So v equals x. Now, so uv, x tangent x, x inverse tangent x, minus v du, x over 1 plus x squared dx. So let's say here u equals only this one, u equals 1 plus x squared, then du equals 2x dx. So it will be x inverse tangent x minus 1/2, okay, because when you divide by 2 from here, 1/2 du, and 1/2 integral x dx is just du, and then this one over u. Okay, so then x inverse tangent x minus 1/2, and then integral 1 over u is ln u, so 1/2 ln of u, but u was 1 plus x squared, or you can say x squared plus 1 plus c. So then answer is C. Okay, let's move on to number 5. Now, what is M3 midpoint Riemann sum of 3 equal subdivisions? Okay, so you can find out, in order to do Riemann sum, delta x is b minus a over n, and then you have a 3, okay, 3 subdivisions. So 11 minus 5 over 3, so 6 over 3 is a 2, so delta x equals 2. So what you can do is think about this way. So when you graph it, let's say like this, right? So that graph, then 5 2, let's say 11 you have here, and then your delta x you keep adding, so 7 and 9 and 11. So you have this 3, but you use a midpoint Riemann sum. Okay, so midpoint is right here, 6, 8, 10. Okay, so that means that this time that height. Okay, this time that height right here, when 10, so it meets here, so that height. Okay, midpoint Riemann sum is usually more exact than left-hand Riemann sum or right-hand Riemann sum. So that was a rectangle. Each rectangle width is a 2. Okay, delta x 2. 2 times, you can say f of 6 using midpoint, f of 8 plus f of 10. Okay, so 2 times. When you plug it in, what is f of x? F of x is this. So f of 6 is square root 6 squared plus 1, so root 37. So similarly, f of 8 is square root 8 squared plus 1, so 65, root 65 plus 10 squared plus 1, so 101, like that. So answer C. Okay, using that midpoint Riemann sum. Now number 9, find the trapezoidal sum n equals 4. So you have a 4 trapezoid from 1 to 2, f of x dx, where some values of f of x are given in the following table. Okay, so what you're gonna do. So kind of sketch, you know, because you wanna see, you wanna visualize first. So let's say 1, 1.2, 1.6, 1.7, and 2, like that. And the y value that time 4, 6, and 10, 16, and 20. So you have a trapezoid 1, 2, 3, 4. Those are 4 trapezoid you have. So you can find that what is the trapezoid area is 1/2 base 1 plus base 2 times height, right? So this area approximately 1/2 base 1 is, remember this is a 4 and this one 6 and 10, things like that, 16, 20. So 4 plus 6 times height is, height I'm gonna put here. So their delta x is a height right here. So 0.2, and here 1.6 minus 1.2 is a 0.4, and here just 0.1, here 0.3. Okay, so I'm gonna just put 0.2 plus 1/2. Next one is a 6 plus 10 times 0.4. 2 more, so 1/2. 10 plus 16 times 0.1 plus 1/2. 16 plus 20 times the last height 0.3. Okay, so let's print the calculator. So once you print the calculator, everything, that's around 10.9. So answer B. Okay, that's how you're gonna calculate. So that's a review about Riemann sum and trapezoidal. Now, number 7. So this one also integration by part. So what you're gonna do is, let's say u equals x squared. Okay, and dv is cosine 3x dx. So du equals 2x dx, and v equals, you have to consider chain rule. So 1/3 sine 3x. So uv, so 1/3 x squared sine 3x minus v du. So minus 2/3 integral x sine 3x dx. Okay, and then this portion you can do one more time. So u equals x, and then dv is sine 3x dx. So du equals dx. V, if you consider also chain rule, 1/3 minus, because derivative cosine is a negative sign. So minus 1/3 cosine 3x. So uv minus 1/3 x cosine 3x minus v du. So plus 1/3 integral cosine 3x. So it will be negative 1/3 x cosine 3x plus, if you consider also chain rule, 1/3 times 1/3 is 1/9 sine 3x plus c. Now only that portion going into here. So your final answer, so let's see, 1/3 x squared sine 3x minus 2/3 negative 1/3 x cosine 3x plus 1/9 sine 3x and plus c. So when you simplify, let's see, only that portion here, so plus 2/9 x cosine 3x and minus 2/27 sine 3x, right? Plus c. So right answer then should be B. Okay, B is equivalent to that one. Okay, so let's move on. Number 8. So this one, since you have a square here, we're gonna use a power reducing formula. What is a power reducing formula? I want to memorize it. So power reducing formula is sine square x is 1 minus cosine 2x over 2. So it used to be second power here, but now only one first power. So it's we call power reducing, or you can say half angle formula. Cosine square x 1 plus cosine 2x over 2. So those two you need to memorize. Now, so I'm going to use this one for that. So if you convert that cosine, 1 minus cosine 2x over 2 dx. So 1/2 x and minus 1/4. Okay, maybe to split it if I skip anything. Integral 1/2 dx minus 1/2 integral cosine 2x dx. You can split it first. And then you take antiderivative 1/2 x minus, then consider the chain rule. So 1/4 sine 4x plus c, right? And then when you take out, this is a 2x. So you can do a little more. 1/2 x minus 1/4. Sine 2x is a 2 sine x cosine x, right? Plus c. Then one of the two cancel out. So 1/2 x minus sine, so it'll be just 2. So then it should be d. Okay, so use a double angle formula. So sine 2x 2 sine x cosine x. So we call double angle formula. Okay. Now let's move on. Number 9. So how are you gonna do this? Now let's say then also using Liat. So u equals x cubed, right? U equals x. Let's say u equals inside here. Because that's not just x. So I'm gonna say u equals x squared. Then du equals 2x dx. I'm not doing integration by parts right now because this is a complicated inside. So usually if you have a sine cosine inside complicated, that is a u. Okay. So then what happened here is integral. Then I can change into x sine x squared, and then x squared. No, actually. So x cubed, I'm gonna split it. X squared, sine x squared, and then x dx. The reason why I split it, because x dx will be 1/2 du. So this one will be x squared was a u, and then sine u, and then x dx is 1/2 du, so 1/2 du. Okay. Now you can use integration by part. Okay. So let's see. I'm gonna say, for my convenience, I'm gonna do just x sine x dx like that for now. But this x is a u. So let's say u equals x, and then dv is sine x dx. So then du equals dx. V is a negative cosine x. So negative x cosine x minus b du, so plus cosine x dx. So negative x cosine x plus sine x plus c. But now what I'm gonna do, so I still need to multiply 1/2, so negative 1/2. My x was u is x squared, right? So this one x squared actually, and cosine x squared plus sine x squared plus c. Now if you look at the answer choices, that's a c. Oh, in here actually it was this, right? So yeah, should be then c. Okay, because that one I have to put parentheses 1/2 times that. Okay. Now number 10. Let's move on. Now then from here, so in this case I know if I make it u equals cosine x, then sine x dx will be du, right? So du negative sine x dx. So that equation converted to u cubed. Sine x dx is a negative du. So negative 1 over 4 u, but cosine x I substitute back, force power plus c. Then answer D. Okay, just that was a pretty easy use up. Now here, if you have a sine cosine together like this, and then power is more than 1, then use always try to manipulate the odd power 1. Okay, so I don't have much space, so let me write down here sine square cosine cube. So sine square x cosine cube x dx. So how are you gonna do that? So that was the number 10. So what I'm gonna do, like I said, sine square x, and then this one, cosine square x, and cosine x dx. So I know if I make it sine, u is a sine, then this one will be du. So another formula you need to know, sine square x plus cosine square x equals 1. We call Pythagorean identity. So sine square x, instead of cosine square x, 1 minus sine square x, right? When you subtract sine square x both sides, so it'll be 1 minus sine square x and then cosine x dx. Now, so sine square x minus sine force power x, cosine x dx. So let's say u equals sine x. Then u square minus u to the fourth power, and du equals cosine x dx. So that one du. Okay. Now, so 1/3 u cubed minus 1 over 5 u to the fifth plus c. So you substitute back. So 1/3 u was sine x here. So sine x cubed minus 1 over 5 sine x fifth power plus c. That should be your answer. So if you look at that, number 10 and number 11, then answer is A. Okay, 1/3 sine cube x minus 1/5 sine fifth x plus c. Okay, that's what I have here. Okay, let's move on. Now, next one, number 12. Let me erase it here. So how are you gonna do this? I know if I make it u equals tangent x, then this one is du, right? Because derivative tangent is a secant square. So let's put that way. Let's say u equals tangent to x, then du equals secant square to x times 2 dx. Okay, chain up. So it will be u and then 1/2 du. Okay, so then 1/2 u square plus c, then 1 over 4 u is a tangent to x square plus c. So you don't have that. So looks like they use identity. So another identity we know, 1 plus tangent square x equals secant square x. Okay, so you can say tangent square x is secant square x minus 1. So 1 over 4 tangent square to x, I can say secant square to x minus 1 plus c. Then that is 1 over 4 secant square to x minus 1 over 4 plus c. But this one is a still unknown constant, so you can just say c. So answer D. Okay, so negative 1/4 plus c will be just you put it another c, because c still will be decided by like initial condition. So you can just put it whatever constant is holding, you can put it as a just c. Okay, so answer is D. Now number 13. So this one, I see that kind of inverse sign. So let's see here. Erase it here. So number 13. Integral 1 over root 1 minus, I see that this way, 2x squared dx. So let's say u equals 2x, then du 2 dx. Okay. Then integral 1 over square root 1 minus u squared dx is 1/2 du. So that's 1/2. That's the inverse sign of u. Okay. So that is answer. So 1/2 arc sine. Yeah. So B should be answer. Okay. Arc sine, inverse sine, same thing. Now let's move on. Then number 14. So this one, what you can do is, why don't I take out, because I see that arctangent there. So you can, 25, you can take it out. 1 plus 4x squared over 25 dx, like that. So 1 over 25, you can take it out. 1 over 1 plus, this one make it something square. So 2x over 5. Because 2x over 5 squared will be 4x squared over 25. So let's say u equals 2x over 5. So du is 2 over 5 dx. Then it will be 1 over 25 integral 1 over 1 plus u squared. Instead of dx, you put it 5 over 2 du. Now this one cancel. So 1 over 10 integral 1 over 1 plus u squared du. So that's the inverse tangent. 1 over 10 inverse tangent of u, but u was a 2x over 5 plus c. So 1 over 10 arctangent, so D will be your answer. Okay. Now let's move here. So I see that this one, you have to split. That's another method we call partial fraction decomposition. So let's put it this way. 1 over, when you factor x minus 3, x plus 3, let's put it a x minus 3 plus b x plus 3. Okay, I'm gonna change this one before you take antiderivative. So when you multiply x minus 3 x plus 3, okay, every term, then it will be 1, and 8 times x minus 3 cancel, but you have a x plus 3 plus b. Now this time x plus 3 cancel, it's x minus 3, like that. Okay, of course the one is this whole thing cancel out this one. Now you can substitute x equals, let's say 3, then left hand side is still 1, then a times 3 plus 3 is a 6a, and then b will, this one will be gone. That's why I pick x equals 3. So a is a 1 over 6. Now when you pick x equals negative 3, 1 equals, this time this one gone, right? So then negative 6b, so b is negative 1 over 6. So I can rewrite as that a was a 1 over 6 and a 1 over x minus 3 dx, minus 1 over 6 integral 1 over x plus 3 dx. Okay, it will change it like that. This one be like that. Now 1 over 6 ln of x minus 3 minus 1 over 6 ln of x plus 3 plus c. Okay, it looks like they combine. So then when you take out 1 over 6 ln x minus 3 minus ln x plus 3 plus c, then use one of the logarithm rule, ln x minus 3 over x plus 3, right, plus c. So if you subtract here, then you can put it this one as a fraction. So ln a minus ln b is ln a over b. Okay, that's one of the rules I use in here. We call subtraction rule for logarithm, then you divide it. Okay, so then answer D. Okay, now let's move on to 16. So also this one partial fraction decomposition. So I see this one x plus 3, x minus 2. So let's say A, x plus 3, B, x minus 2. So again, I multiply here by x plus 3, x minus 2 every time. So 1 equals A, x minus 2, plus B, x plus 3, like that. So let's say x equals 2. When you substitute, 1 equals this one gone. So 5b. So b is 1 over 5. When you plug in x equals to negative 3 this time, so this one gone now. So 1 equals to negative 5a. So a is a negative 1 over 5. So now that becomes a was a negative 1 over 5. You can take in the front, 1 over x plus 3 dx. Plus b is a 1 over 5. You can take it also. 1 over x minus 2 dx. Okay, so there will be negative 1 over 5 ln of x plus 3, 1 over 5 ln of x minus 2 plus c. Looks like they combine again. So what you can do is 1 over 5 ln x minus 2 first minus ln of x plus 3 plus c. So subtraction, like I said before, ln x minus 2 over x plus 3, right? You can make it as a fraction. So E will be your final answer. Okay. Now, next one, how are you going to do this? Okay. First step, you can just split it first. So 2x squared plus 1 dx plus 1 over x squared plus 1 dx. You can split it. Now, this portion, I'm going to use u sub. So u equals x squared plus 1. That, well, how do you know? Because I know when you take a derivative, it will be like x dx comes out. So du equals 2x dx. Okay, you see that? 2x dx comes out. So it will be integral then du over u plus, this one is inverse tangent x, right? Itself, this one. So then this one is ln u plus inverse tangent x plus c. So d will be your final answer. Okay, you split it. Now, how are you gonna do this? Okay, so integral 0 to r f of x dx, they gave you whatever here, and then 0 to infinite f of x is what? Okay, so this one indefinite integral, so I'm going to use a limit concept. So let's say limit b goes infinite and then 0 to b. Okay, this one becomes I replace by b, and then that one then f of x dx, like that. Okay. Oh, actually, I'm gonna replace this one by r. Okay, because that's just like variable. Okay. Now, so limit then r goes infinite. I replace this one like here. If you remember horizontal asymptote, if it's just same power and then x goes infinite, take the coefficient. So we know that 2 over 1 answer is a 2. You already know the answer. But to prove it, you might be wondering how you're gonna do that. So then you divide by r squared top and bottom. So then limit r goes to infinite, 2 minus 5 over r squared, 1 plus 1 over r squared. But if r goes infinite, denominator is huge, so it will be 0. So only 2 over 1 left. So answer is 2. Okay. Now, how am I going to do this? So limit also change it, b value, b goes to infinite, 1 to b 1 over x squared plus 1 dx. So that is arctangent. B goes to infinite. So that's the inverse tangent. So inverse tangent x, 1 to b. So when you plug in b, limit b goes to infinite, inverse tangent b minus inverse tangent 1. So inverse tangent infinite is pi over 2. Okay. Inverse tangent 1 is a pi over 4. So pi over 2 minus pi over 4 is pi over 4. So answer B. Okay. And then last one for this first video. Now, so what you have to do is, that one is inverse sine, right? So basically, you can say arcsine x -1 to 0. So arcsine 0 minus arcsine of -1. So if you consider arcsine range always negative pi over 2 to pi over 2 here. Okay. So what angle becomes a 0? 0 is a 0. Okay. -1. That is a negative pi over 2, right? Sine negative pi over 2 is -1. So it will be pi over 2. So answer D. Okay. So that's it for this video, and then I'm gonna post another video for second test prep for integration technique.